Hello, everyone. Can you hear me clearly? I can see only one. Katra, can you hear me clearly? Okay, right. Okay, thank you. All right. So let's wait for maybe 15-30 seconds to check whether anyone else is joining our meeting, right? Otherwise, I will carry on. Yeah. Yes, Kara, this will be recorded. Yes, you can view it later. Yes. And okay, if you have any questions, you can go ahead and speak out. It's completely okay.
I don't have any questions.
Okay, right. So what I plan to do today is this. I will. Okay. So we have another guest. Yes. Okay. We have a few more coming in. Okay. So let's wait and see. Right. Um. Right. So I will tell you the plan up to now. Right. You can go ahead and add to that plan if you like. Right. Because there's only few people here. So you can make any suggestions if you like. Right. I can um, amend the things that I plan to do depending on what you ask me to do, right? So based on the questions that I had through emails and those uh, on mainly through emails, I found that some of you have questions, especially in later chapters, starting maybe from chapter 9, 10, sorry, 9 and 11 mainly, right? Maybe I can add chapter 8 as well to that, right? So chapter 8, 9, 11. So it's true that those chapters are the hardest ones out of all the chapters that you have from the beginning till the end. So I mainly try to focus on those questions because I will not have time to discuss the whole review, right? So so my plan is to start from question number, let me share the screen first. Okay. Question number 31. Okay. So I will start from question number 31 and I will discuss till the end from there onwards. Okay. And if you have any questions before that, like in between question number 1 to 30, right? You can go ahead and ask those questions right now. Just tell me the question number and I can discuss that. Okay. And my plan is to start from 31 and finish till the end, which is question number 50. Yeah, 51, right? So I will discuss questions starting from 31 to 51 today. That's my plan. But if you think, if you have any questions from question number 1 to 30, you can go ahead and ask. Just tell the question number and I will discuss that. Okay. Is the plan clear for today? And can you all see the screen clearly? Can you all see? I'm sharing the screen. Can you all see the screen? Okay, let me see this. Something in the chat. Yes, okay, thank you very much. Right. Now, okay, let me start from question number 31 then, right? Okay. Question number 31. A researcher for a car insurance company wishes to estimate the mean annual premium uh, that men aged 20 to 24 pay for their car insurance. A random sample of 16 men aged between 20 and 24 yields the following annual premiums in dollars. Use the data to the right to obtain a point estimate to the mean annual premium for all men aged between 20 to 24. Now, in statistics, we do this mainly, right? We try to estimate things, right? We try to estimate a characteristic in the population. So, for example, we the population is the bigger thing that we are interested in, right? To get some information about this population, what we do is we take a small sample, and based on the sample, right, we try to estimate this population characteristic. So what do I mean by population characteristic? It may be the population mean, it may be the population standard deviation. uh, so the characteristic may vary depending on the question. Here we are interested in estimating the population mean. Okay, so to estimate the population mean, what we use is the sample mean. Okay, so what we do, let me draw this to represent the population. Okay, population is the bigger thing. That means uh, in this particular question, it will represent all the uh, male car insurances, right? Men aged between 20 to 24 pay for their car insurance. So here's a sample of 20. Now we depend, based on the sample of 20, we try to predict or estimate uh, the mean annual premium for all men, right? Age between 22 to 24, right? So the population is the bigger thing. That means all the you know uh, premium car rental. Sorry, I can't. Let me see what's. Um, yes, all the annual premium for all men, right, represents this population. Now we cannot access the whole population. So what do? We take a small sample, okay, and depending on the sample, we try to estimate this population characteristic, which is the mean of the population in this particular question. Now, to estimate the population mean, we use the sample mean. We denote it by x bar. Okay. So this question, even though it looks little complicated, it is very simple. What it asks you to do is to find the sample mean for this particular set of data, of these 16 data points. So, so we estimate the population mean using the sample mean, and we call this sample mean a point estimate. Okay, so this is a point estimate. Why is it called a point estimate? Because it only gives one value, okay, one single point to this population mean, usually denoted by mu, right? So we want to capture this guy, mu, okay? And we use the sample mean to capture the population mean, mu, okay? And the sample mean is called, a point estimator, right? And once we have a value to that, right? So for example, we take the sample, so we have these 16 people, and we calculate the sample mean, and that value, we call it the point estimate. Okay, x bar is the point estimator, and the value it gets, depending on the sample that we observe, is called the point estimate. Okay, so how do we calculate the point estimate here? We simply find the mean of these 16 people. Okay, so what do you need to do? You simply need to add all of these values, 459, 585, okay, until 985. You add all of these values and divide by the number of observations, which is 16, right? So 459 plus, yeah, that will make things easier for me. So x bar is 459 plus 585 plus, I'm not going to write all. So sorry, the last value is 985, and you have to divide this by 16. You will get the sample mean, and that will be the point estimate for the population mean. That's what the question is asking, right? So when you do this, you will get the answer as 693. Okay, 693, which is B. Okay, question 31. Right, question number 32. Question number 31 is about point estimation, right? And that's the only question that you have uh, regarding point estimates, right? We mainly use interval estimates when we are estimating things, okay? So again, to be clear, this is what we are doing simply. We have this bigger thing, population, right? We want to estimate something, some characteristic in the population. For example, in this previous question, we want to estimate the population mean, right? So what do? We take a small portion, right, from this population, which we call the sample, right? Because we don't have time and money to access this population most of the time. So what do? We take a small portion out of this population, which we call the sample. And based on the sample, we try to estimate the thing that we want in the population, right? Now, this is estimation, right? You have the population, you take a small sample and try to estimate the population thing. Now, this estimation can be done in two ways. One, we just discussed. The first thing is called the point estimation. Okay. There, we only give one single value, right? So we want the population mean in the previous question. We gave this one single value of 693, one value, right? To estimate this population mean. Okay. And the other method is what I'm going to describe now. It is called the interval estimation. In interval estimation, instead of giving one value, we are going to give an interval, right? For example, we're going to say the population mean should be, instead of saying one single value like this, 693, now we are going to say it should be in between 690 and 695, something like that, right? So the answer would look like this, okay? Now, the good thing about interval estimation is this. When we are giving an interval, right, of values for our estimation, we can say something about the probability of this mean being equal in between these two values. Okay, so that is also considered when doing this interval estimation, right? So in summary, right, what you need to know is this. When estimating things in the population, we can use two techniques. One is the point estimation, where you give one single value to uh, for the population parameter. And the second way is to give an interval of values, which is called the interval estimation. Now, the interval estimation that we use more frequently, okay? So when it comes to interval estimation, right, you simply need to use this few formulas, right? So let me quickly go through them, right? So under chapter 8, right? So a z interval for the mean mu is given here, right? So this is one of the main formulas that you need to use, okay? And the other is the studentized version, right? This, okay? So let me write this down. In interval estimation, we mainly use two formulas to estimate the population mean, right? Population mean, right? to estimate the population mean, we use these two formulas, either this or I will have a n minus 1 usually, which is not indicated in this equation, just a subscript here, right? So s over square root n, okay? So I will tell you why I put a n minus 1 here later on, right? But it's just a subscript, right? So it's not going to affect the equation, right? So these are the two main formulas that we use to make an interval estimation, okay? So if you look at these two formulas, you will see something common. That is this. This x bar is what? When we are estimating the population mean, x bar is the point estimate. Okay. So in interval estimation, inside the interval estimation equation, we have point estimate value as well, right? So we have to use this point estimation part a little bit when we are making this interval estimation, right? And this region, this plus or minus part, right, is called the error that we allow, okay? Okay, sorry, margin of error, right? Sorry, margin of error, margin of error, okay? So basically, what we are doing is in interval estimation, right? Interval estimate is equal to point estimate, right? You can see this point estimate plus or minus the thing called the margin of error, okay? So the margin of error in the first equation is this, margin of error in the second equation is this, okay? Now, you need to understand these two concepts when it comes to answering questions, right? Because both methods will be useful to answer these questions. Let's see question number 32, right? Based on a sample of 31 randomly selected years, 90% confidence interval for the mean annual precipitation in one city is from 48.8 inches to 51.2 inches. Find the margin of error. So these types of questions, right? Now, in this question, you are given the interval estimate. You are not asked to find the interval estimate. Instead, you are given the interval estimate. What is the interval estimate? A 90% confidence interval for the mean annual precipitation in one city is from 48.8 to 51.2. Okay. So this is the interval estimate. It is given to you. So when they give you the interval estimate, they ask for something else. What are they asking? They're asking for the margin of error. Okay. Now to answer this question, you have to understand the margin of error in this form. Okay. So how do we create the interval estimate? Okay. Interval estimate is equal to point estimate plus or minus margin of error. Okay. I abbreviated it like this, right? Interval estimate is IE, point estimate PE, plus or minus the margin of error ME, right? Now, if I try to draw a picture for this, the interval estimate is created by taking this point estimate value, which is X bar, and you add and subtract some value from it, which is called the margin of error. You add the margin of error to the point estimate, and then you subtract the margin of error from the point estimate. So what you do is you take the point estimate, you create the interval estimate by adding the margin of error and subtracting the margin of error from it. Okay, so that's how you create this interval estimate. This is what you need to answer this question. Now, what can you tell about this total length of this interval estimate that we get? Can you see that it is equal to how many margin of errors? From the point estimate, we create the interval estimate by doing this. Take the point estimate, add the margin of error, you will end up in here. Take the point estimate, subtract the margin of error, you will end up somewhere to this side here, right? So what can you tell about the total length of this interval estimate? How many margin of errors are there? Any answers? Can you see that there are two margin of errors here? Because this is equal to a margin of error distance, this is equal to a margin of error distance, and this whole thing is equal to two margin of errors. So we have an equation like this. The length of the interval, okay, length of the interval estimate is equal to 2 times the margin of error. I will simply say length is equal to 2 times the margin of error. Okay. Now, in this particular question, can we find the length? Yes, because we are given the interval estimate and it is 48.8 to 51.2, right? So 48.8 is the lower limit of the interval estimate and 51.2 is the higher limit of the interval estimate. So what is the length of the interval? It's simply 51.2 minus 48.8, right? Which is how much? 1.4. Am I correct? 50. Oh, sorry, 2.4, right? Yes, 2.4, right? Now, you know the length now, right? If you know the length, what is the margin of error? So the length is 2.4. Length is 2.4. It should equal 2 times the margin of error. So margin of error should be half of this value, right? In other words, you simply divide this by 2, you will get the margin of error, which is 1.2. Okay. So the margin of error, 32, answer is B. Okay. Right? Okay. Now, if you have any questions, you can ask. I'm going to discuss these questions, assuming that you have read all of these theories, right? So yes, I am going to describe the theories somewhat, but I'm not going to discuss in detail everything, right? So I hope you have done the homeworks and you have looked at the notes so that you have some kind of understanding beforehand, right? So assuming that I'm discussing these questions, right? But still, if you have any questions, if you have anything that you didn't understand, you can go ahead and ask, right? Okay, that is question number 32. Now let me go to question number 33 and I will make this question. I will try to go through these questions a little bit faster now. Okay. Now, question number 33, yes, asked to construct a 90% confidence interval for the population mean. Okay. A random sample of 120 light bulbs had a mean life of 480 hours. Assuming that sigma is 36 hours, construct a 90% confidence interval for the mean. So this is the typical types of questions that you would get, right? So the confidence intervals, you have to create a 90% confidence interval. Okay. So confidence interval and interval estimate both are the same. Okay. Interval estimate. Okay. If you say interval estimate or a confidence interval, they both mean the same thing. Okay. So here we want to create a 90% confidence interval. Okay. That means we have to be 90% confident about the estimate that we are giving in, right? In other words, we are 90% sure, we should be 90% sure that the actual population mean will be within these values. Okay, right. So how do we do it? Now, to when it comes to interval estimation, there's only two equations. You have to pick the correct one out of these two. Okay, first one, x bar plus or minus z alpha over 2 sigma over square root n, and the other is x bar plus or minus t alpha over 2, I will additionally put n minus 1 there, s over square root n. These are the two equations that we use to make an interval estimation for the population mean. Now, out of these two, which one should you pick? The easiest way in the questions that you get, right? The easiest way to pick which equation out of these two, right, is to look at the information given and look for this guy here. Okay, the main difference comes from there, right? The first equation we use when sigma is known, that means the population standard deviation sigma is given to you. We use this one, right? We use this equation. If the sample standard deviation s is given to you, in that means sigma, the population standard deviation, is unknown, right? If it is unknown, you will be given the sample standard deviation, right? If that is given in the question, we have to use this equation, this guy. Okay, again, if the population standard deviation sigma is given, you use this guy. If the sample standard deviation is given, you use this guy. Okay, now let's read the question again. A random sample of 120 light bulbs. Let me write down the things when I'm getting them, right? Samples, a random sample of 120 light bulbs means sample size n is 120. Okay, had a mean life of 140 hours. So x bar is straightforwardly given. X bar is 480. Okay, and sigma is 36. And this is very important. Why? Because at this point, you can decide out of these two which equation to use, right? Here you are given sigma, that means the population standard deviation. If the population standard deviation is available, or it is given to you, or if it is known, right? Here it is known, so you have to use this guy. If it is not given, instead something like this is given, a sample standard deviation is 36, right? If something like this is given, you have to use this equation. But in this question, the population standard deviation sigma is given to you. So that means you have to use this equation, right? So this is out of the way for this particular question, right? So now you know which equation to use, and afterwards it simply plug into these values. Okay, so x bar 480 plus or minus z alpha over 2 for a 90% confidence interval. Z alpha over 2, how do you find z alpha over 2? I think you will be comfortable with it now, right? So if you have a 90% confidence, 90% confidence means, right? 90% confidence means 10% you are not confident, right? The rest of the 10% you are not confident. That means that is the error that you are allowing, right? So that error we're going to split into two as 5% and 5% like this, right? And you will see, right, when you have this 5% level to this side, the z value here is going to be 1.645. Okay, if you have any questions about how I get that answer, you can go ahead and ask. I can explain in detail how to get this. Okay, so 480 plus or minus 1.645, sigma is 36 over square root n is 120. So you do this, you do the calculation. Now you know which equation to use and what to do, right? You use this equation and you will find the answer as 474.6. When you when you subtract this side from 480, you will get 474.6. When you add this part to 480, you will end up in 485.4, right? So the answer is going to be C. Okay. So when you write this thing, the statistical part is done, right? You know statistics if you can write this, right? That afterwards it's using the calculator properly, do the calculation properly and getting to the answer, right? Okay. So the main thing that you need to check is to write this thing down first, okay? Which equation to use out of these two, and then plug in the values correctly, then do the calculation using the calculator, right? Okay. Okay. 33. Sorry, 33 we finished, 34 now. Okay, so this is a different type of question, right? A completely different type of question. Weights of women in one age group are normally distributed with a standard deviation sigma of 20 lbs. A researcher wishes to estimate the mean weight of all women in this age group. Find how large a sample must be drawn in order to be 90% confident that the sample mean will not differ from the population mean by more than 2.4 lbs. So this researcher, the main thing, right, is to find the sample mean, sorry, sample size such that the sample mean will not differ from the population mean not more than by 2.4 lbs. Okay, that's the maximum margin that we are allowed to go, right? Okay, so let's see which equation to use here, right? So there is a separate equation in this whole syllabus. There's only one equation to find sample size, and it is given here, right? Sample size for estimating mu is this. Okay, so n is equal to z alpha over 2 sigma over e whole thing squared. Okay, so for a 90% confidence, okay, to be 90% confident, right? So the 90% confidence will give us the value for z alpha over 2. Okay, how do you find it? If you are 90% confident, the error that you allow is 10%, and this is actually alpha. Okay, the error that you allow is alpha. 10% means alpha is 0.1. 10% as a probability is 0.1, right? And we're going to split this alpha into two equal parts like this. If you split 0.1 to two equal parts, it will become 0.05 and 0.05. As a percentage, it's 5%, 5%. Okay, so 0.05, 0.05 to both sides. And when you have 0.05 to this side, the value here is going to be 1.645. Okay, the z value here is going to be 1.645. So z alpha over 2 is going to be 1.645. Okay, so that is done. And what else is given? Sigma is straightforwardly given in the question as 20 lbs, right? With a standard deviation of 20. So sigma is 20. E is the amount that we are okay to go to the two sides. Here, this researcher wants the sample mean uh, to be within 2.4 lbs from the population mean. So E is going to be this 2.4 here. Okay, E is the amount, the error that the researcher is comfortable with, right? because we cannot find anything exactly in a pinpoint manner, right? There is always a small error, right, in anything that we find. So this researcher is okay with within 2.4 lbs, right? If his answer is, if the he tried to capture the sample mean, and it should be within 2.4 lbs, right? So this error that he's okay with is E, which is 2.4. Now we have everything, right? Simply plug into this. 1.645 times sigma is 20, divide by 2.4, whole thing squared, okay? And you do this and make sure that you have to round up your answer, okay? So let's say you get, I don't have the exact answer here. Let's say you get 187.1, okay? If you get such an answer, still you have to round it up. You're not rounding, you're rounding up. That means you're going always for the higher value. If it is 187.1, your final answer should be 188, right? That is how you round up. You always go to the higher number. If it is 187.9, still you round it up, you will end up in 188, right? You always go to the nearest whole number that is above that point, right? That means 187.1 or 187.2, anything, right, will round. If you round it up, you will end up in 188, right? Round it up to the nearest whole number, right? Okay. So I don't have the exact answer here, but once you round it up, you should get the answer as 188. Okay, so the answer there is B. Okay, you can check what's coming up from this equation, right, using the calculator, and you always round up. Once you round up, you should end up in 188. Okay, so that is question number 34. 35. Okay, this is an easy question. For a t curve with a degrees of 4, find the value of t 0.05. You simply need to use this table in this formulas and table sheet, right? I hope everyone have the access to this formulas and table sheet, and this is also uploaded in the Blackboard, right? If you don't have it, you can find it there, right? Okay, so the question, okay, let's go to this t table and let's see what they want me to find. Degrees of freedom for t value 0.05. T value 0.05 is under this column, and the degrees of freedom is the other thing that you need to figure out this t value. Degrees of freedom is given here, and degrees of freedom 4 is what we are interested in. So where these two things meet will be the answer you need, 2.132. The t 0.05 comma the degrees of freedom 4, I will denote this like this, right? T value for 0.05 with degrees of freedom 4, I will denote it like this, t 0.05 comma 4, and the answer is 2.132. Okay, so 35 answer is C. Okay, answer C. 36. Okay, 36. Okay, 36 is, okay, let's read this question. 30 randomly selected students took the calculus final. If the sample mean score was 75, okay, I will write that down. Sample mean is X bar, right? So that is 75. And the standard deviation was 5.1. This is very important. So this sentence is talking about the sample, right? If the sample mean, sorry, if the sample mean is 75, and the standard deviation, that means the sample standard deviation, is 5.1, because this sentence is totally talking about this sample, right? So I cannot write this. Sigma is 5.1, wrong. Why? Because it is not the population standard deviation. It is the sample standard deviation. Note that very carefully. So S is what is given to you. S is 5.1. Sample standard deviation is 5.1. This, this is very crucial, because depending on whether you know the population standard deviation or sample standard deviation, your equation will change. Because for interval estimation we have two equations, right? X bar plus or minus z alpha over 2 sigma over square root n, x bar plus or minus t alpha over 2 comma n minus 1 s over square root n. Now you choose out of these two depending on whether you know the population standard deviation or sample standard deviation. In this particular question, you don't know the population standard deviation. Why? Because the sample standard deviation is what's given in the question, right? Sample means cos 75 and standard deviation 5.1. So sample standard deviation is what you know, right? Therefore, now you know which equation to use. Is it this or this? Which one? If the sample standard deviation is known, you pick this guy. This is out of the way, right? You use this when you know the population standard deviation sigma, but nothing is mentioned about the population standard deviation here. Sample standard deviation is what you have in this question. Therefore, you have to pick this equation, okay? Right, now x bar is there, okay? S is there. Sample size should be there somewhere, right? 30 random, okay, it's given at the beginning, right? 30 randomly selected students. So n is 30, right? So the only thing I need to find is this t alpha over 2 comma n minus 1, right? So let me find it, right? T alpha over 2 comma n minus 1. Now, what is alpha here? Alpha is the error that we allow. So if we are 99% confident, so this confidence level is what helps us to find this alpha, and later on alpha over 2, then T alpha over 2, right? So if you're 99% confident, that means you're 1%, the you're 1% not confident, right? That is the unsurety that you have, that you allow. This is the error actually that we allow. So if this 1% is the alpha, right? Alpha is the error. Alpha is the notation that we use to denote the error, right? So if we are 99% confident, we are not sure about the rest of the 1%. So that is our alpha. This 1% written as a proportion is going to be 0.01. Okay, 1% is 0.01 as a fraction, right? As a decimal, right? So if alpha is that, we need alpha over 2 in this t case. So alpha over 2 is going to be this divided by 2, which is 0.005. Okay. Okay. Now, n minus 1 is the degrees of freedom. So that is always n minus 1 in this case, right? In your syllabus equations, the degrees of freedom is always equal to sample size minus 1. So the sample size is 30. 30 minus 1 will give me 29. So we want T alpha over 2, which is 0.005 comma 29. Okay. So let's go ahead and find this value in the table. T 0.005 is here. Okay. And we need the degrees of freedom 29. 29 degrees of freedom is along this line. So the value that we need is here, which is 2.75. 2.750. Okay. Right. Now we simply need to plug into this equation, right? What is the equation? X bar plus or minus T alpha over 2 comma n minus 1 S over square root n. when you plug in x bar, we know that it is okay, x bar is how much? 75 plus or minus. We found T alpha over 2 as 2.750 times S is 5.1 divided by square root n, which is 30. Okay. Now you have done the statistical part. Now it's about using the calculator properly and get into the answer, right? And you will see that for 36, answer is A, which is 72.43 to 77.57. Okay, that is question number 36. Okay, question number 37. Okay. Question number 37 is from hypothesis testing. Okay. When it comes to hypothesis testing, you need to know several things. This is chapter 9, right? Chapter 9. You always have two hypotheses. Okay, one is called the null and the other is called the alternative. And out of these two hypotheses, the null hypothesis always contains the equality sign, and the alternative hypothesis have three ways, right? That means alternative hypothesis can be a not equal sign, greater than sign, or less than sign. What do I mean by this? Let me write down two things, right? Let's say um, okay, let's look at question number 37. That will help me to write down the null and alternative, right? At one school, the average amount of time that 10th graders spent watching television each week is 21.6. So this will tell me that the average is 21.6 right now. Okay, so that should, the equality should always go to the null, right? The principal introduces a campaign to encourage the students to watch less television. 1 year later, the principal wants to perform a hypothesis test to determine whether the average amount of time spent watching the television per week has decreased. Okay. Now, in this case, the principal is interested in whether after introducing this new method, the hours that students watch television has decreased. So he's interested in whether the mean is less than 21.6. Okay, that's what he's interested in. The thing that we want to test, the researcher's interest here, the researcher is the principal, right? So he's interested in seeing whether after introducing this method, the number of hours that students watch television has decreased. So he's interested in this hypothesis. That goes to the alternative, right? Null, you don't have to think about anything. It's always the equality, right? Alternative is the one that changes depending on the question, right? And for example, if he's interested in something like checking whether the mean time has increased, then your alternative would become something like this. Okay. Or else, if he's interested in whether the mean time has changed from this previous amount, then he is interested in alternative hypothesis like this, not equal to 21.6. Why? Because he's looking at a change. It can be a decrease or increase, right? So if he's specifically looking at a decrease, your alternative should look like this. If he's looking at an increase, your alternative should look like this. If he's looking whether it has changed or differed from this previously mentioned amount, he's looking at a hypothesis like this, alternative hypothesis like this, right? So the alternative can appear in three ways. Depending on the question, it will be either this, this, or that, right? For this particular question, he's looking at the mean time has reduced or is whether it has uh, the mean time that the students watch TV is less than the previously mentioned amount. So therefore, he is interested in this particular alternative in this case, right? So, okay, so I just wrote these two to tell you that there are two other ways that the alternative can appear, right? Okay. If he's looking for a lesser thing, it should look like this. If he's looking for an increment or a higher thing, it should look like that. If he's looking for a change, it should look like not equal to, right? You will encounter them later on, right? Now here he's looking whether the mean time has decreased. So this is the null and the alternative here. Okay. And when you have looking at the alternative, you decide whether it is a right tail, left tail, or two tail. So this, sorry, 21.6, right? Sorry. Okay. When you have this way in the alternative, right? Mu less than some value in the alternative. This is called a left-tailed test. Okay. So this is a left-tailed test. Right. So that will also be helpful in later questions. That's why I just mentioned it here. Right. So for question number 37, answer is B. Okay. You simply need to write down the null and the alternative. We did it here, right? Okay. Question number 38. A health insurer has determined that the reasonable and customary fee for a certain medical procedure is $1,200. They suspect that the average fee charged by one particular clinic for this procedure is higher than this amount. Okay. Now, at this point, you should be able to write down the null and the alternative, right? So the mean should be at $1,200. The equality should always go to the null, which is H naught. Okay. Alternative is the one that changes depending on the question. It can either look like this, that, mu less than some value, mu greater than some value, or mu not equal to some value. So you have to read the question carefully and decide which one out of these three is appropriate for this particular question. Okay. Here this researcher is checking, right, uh, whether one particular clinic for this procedure is charging higher than this amount of $1,200, right? So he's interested in checking an alternative of mu greater than $1,200. He's checking whether this particular clinic is charging more, right? So the mu is greater than 1,200 is what we want to check. That goes to the alternative, right? So we have written down the answer here, but I will add one to this. So by looking at the alternative, we can decide the type of test that we need to do. That means we have three types of tests: left tail, right tail, or two tail. So if your alternative looks like mu less than some value, it is a left tail test. It is called a left tail test. Okay. If your alternative looks like mu greater than some value, it is called a right tail test. If your alternative looks like mu not equal to some value, it is called a two-tailed test. Okay. So this is a right-tailed test because the alternative, you always look at the alternative when you decide whether it is right tail, left tail, or two tail, right? Now the alternative looks like this, right? Mu greater than some value, right? So it is a right tail test. However, we don't need that to answer the question. We just simply need to write down the null and alternative for this particular question. 38. So the answer should be B. 38, answer B. 39. Okay. In the past, the mean running time for a certain type of a flashlight battery has been 9.4 hours. The manufacturer has introduced a change in the production method and wants to perform a hypothesis test to determine whether the mean running time has increased as a result. So the hypothesis, now it should be clear. It should be like this. Okay. Now, this question is about type 1 and type 2 errors, right? Okay. Okay. So for this exam, you don't need to worry about type 1 and type 2 errors, but I will explain briefly what type 1 and type 2 error is, just for your understanding, right? Okay. But you don't need to worry about 39 and 40 questions for the final exam, right? So type 1 error. Now, when we are doing hypothesis testing, we can do two types of errors. Okay. Now, to understand the error, we have to assume that we know the actual thing going on in the population, even though we don't know it. In practice, we will not know it. But to understand the concept of this type 1 and type 2 errors, we should assume that we know what's going on actually, right? So let's say in the population, right, in the actual thing going on the population is that the null is true, h naught is true, right? Or h naught is false. Those are the two things that can happen, right? The null can be true or false. Those are the two possibilities that can occur, right? And based on the sample, we decide null is true or null is false. Okay, let me write down true and false. That makes it more. So in the actual population, you can have two scenarios. Null is true, or alternative is true, which is null is false. Okay. Based on the sample, we make our decision, right? And based on our sample, we might say the null is true or null is false. Okay. So this is what we decide based on the sample. This is what's actually going on in the population. Usually we don't know this, but to understand this concept, we assume that we know what's going on in the population, right? So if the null is true, and based on the sample, we say the null is true, that's the correct decision. No problem there, right? If the null is true, and depending on the sample, we say it is false, right? This is a error that we made. Okay. So we reject the null based on the sample. We are saying that the null is false, but actually what's going on in the population, it is true, right? So this is a wrong decision. So this is an error, and we call this type 1 error. Okay. And similarly, if here another error is happening, it is called the type 2 error, where we say based on the sample that the null is true, but actually it is false in the population, right? And the last thing is also correct here. Both are telling the same thing, right? So null is false, and based on the sample, we are saying that the null is false. That is a correct decision, right? So these are the two types of errors that we mentioned: type 1 error and type 2 error. So in this exam, I will not test you on those two things, right? So you can see that the answer for 39 and 40, I will straightforwardly give them 39D, 40A. Okay, those are the two answers for 39 and 40. But you don't need to know those two for the final exam, right? So you can skip those two if you like, right? But if you have time, just go through it. It will give you additional knowledge, right? Okay. 41. The significance level and p-value of a hypothesis test are given. Decide whether the null hypothesis should be rejected. Okay. Now, when it comes to hypothesis testing, right, the main goal is to decide whether to accept the null hypothesis or to reject the null hypothesis. Okay, so you have a hypothesis, let's say mu equals some value, let's say mu naught, right? And alternative, mu not equal to mu naught, or depending on the question, it can take either one of these three, right? Okay, now this is mu naught. Mu naught just simply represents some other value, right? It can, depending on the question, it can be 10, 20, 101.6, anything that is given in the question, right? So in general, I call it mu naught. Okay, now the main goal is to decide which one out of these two hypotheses are correct. Okay, so we can have two decisions, right? Reject null, that is one decision. That means reject null means this is correct, alternative is correct. And the second decision is do not reject null. That means the null is correct, right? There is a reason. This is the statistical way of saying these things, right? We don't straightforwardly go ahead and say alternative is correct. Instead, we say reject the null, okay? And we again don't go ahead and say null is true, right? Instead of saying null is true, in statistic, we say do not reject null, right? In other words, it's saying that null is correct, right? Out of these two, null is the correct hypothesis, right? But we don't straightforwardly tell it, right? Instead, we say do not reject the null, right? There are reasons for that. So I will not go deep into those things, right? Just note that these are the two decisions that we can make in the end, right? So to make the decision, we have two approaches. Okay, one is called the critical value approach, and the other is called the p-value approach. Okay, so the 41st question is about p-value approach. So basically what we do is this: we calculate a thing called the p-value and compare it with the error that we allow, which is alpha. Okay, now how do we make the decision? If the p-value is less than or equal to alpha, okay, if the p-value is less than or equal to alpha, we reject the null. That's all you need to remember to answer this question. If the opposite happens, we do not reject the null. Okay, so if you can remember this, that's all you need. If the p-value is less than or equal to alpha, we reject the null. That's all you need to know, right? So what is the p-value here? In question number 44, p-value is 0.02, alpha is 0.01. So which one is greater? P-value is higher than alpha here, right? So the answer for question number 41 should be what? We reject it when the p-value is less than alpha. Here, p-value is greater than this alpha given here. So the answer should be do not reject the null. Okay, so the answer, I will call it B. There's two answers there, right? So since it is the second answer, I will call it B here, right? Okay, 41, answer B. Question number 42. The value obtained for the test statistic Z in a one mean Z test is given. Also given is whether the test is two-tailed, left-tailed, or right-tailed. Determine the p-value to 4 decimal places. Okay. A right-tailed test with Z 0.75. Now, this is how you find the p-value. Now, the Z value is given as 0.75, right? If it is a right-tailed test, the p-value is going to be starting from this test statistic value of 0.75 to the right. Okay. If it is a left-tailed test, it should be usually, then this z value will also be negative. Let's say -0.68, -0.68. Then you calculate the area to the left if it is a left tail test. If it is a two tail test, then you have to be careful, right? If you are given a positive value, let's say 0.78, okay, you calculate the area to the right. If it is a positive value, you calculate the area to the right and multiply that by 2 to get the p-value. Okay, so if it is a two-tail test, okay, remember those two few things, and yeah, then you can find the p-value very easy. Okay, let's see. So this is a right tail test and the z value is 0.75. How do you find the p-value? So the p-value is simply this region, starting from 0.75 area to the right. Okay, so how do you find it? Use the z table, right? So you go to the z table. Okay, I think I missed it. Let's see. Okay, go to the z table and look for this probability. Look for this z value 0.75. 0.7 is here, and for the second decimal place you look in this way, right? So 0.75, where these two meet, is the value you need. Here's the value there where 0.7 and 0.05 meets. So 0.75, the probability is 0.7734. But remember this, when you look in the z table, 0.7734 is the probability to this side, okay, not to this side, okay, but what you need is this side, right? But you can get it easily. If to the left you have 0.7734, this should be 1 minus 0.7734 because this is a probability distribution. So the whole area should always be equal to 1. This whole area should be 1. If you have 0.7734 to the left, let me double check whether I got the answer. 0.7734 to the left, right? To the right, you should have 1 minus 0.7734, right? Which is 6, um, 6, 2, 2. Yes, yes. Do I have such an answer? 42. Yeah, yeah. So 42.2266. Yes, 0.2266 is the answer, which is A. Okay. Right. Now, let's move to 43rd question. Okay. 43. Now, here we are asked to make a decision, right? As, based on this critical value approach. Okay. So in critical value approach, we compare two things, right? One is called the critical value, and the other is called the test statistic value. Okay. Now, let's see how to do this now, right? Okay. A sample mean, sample size, population standard deviation are given. Use the one mean z test to perform the hypothesis test at a given significance level. Use the critical value approach. Now, let's see. Let's see how to do this now. Okay, so in the critical value approach, we need these two things. Thing called the critical value and the test statistic value. So the critical value is mainly based on the error that we allow. Error here is 0.01, right? So based on that, we can find the critical value. Okay, so alpha given here is 0.01, right? So what happens is the next thing you need to check is whether this is one tail, two tail, or sorry, right tail, left tail, or two tail, right? So to do that, you have to look at the alternative hypothesis. The alternative looks like this here: mu not equal to 100, sorry, 18.7. Okay, so if the alternative looks like this means this is a two tail test. Okay, now depending on whether it is right tailed, two tailed, or left tailed, you have a different approach to find this critical value. Okay, so let me start from the right tail, right? If it is a right tail test, the alpha will be given in the question, the error that we allow, right? You put your whole alpha to this right hand side of your normal curve and find this value here, z alpha. That will be your critical value. If it is a left tail test, you do the same thing. You give the whole alpha, but now not towards the right, towards the left. And this value will be the, so it will be negative definitely. So I will put a negative z alpha, will be the critical value. Okay. Then if it is a two-tail test, there is a slight difference now. Two-tail test, you have to split your alpha into two parts. Okay. You give alpha over 2 to this side, alpha over 2 to the other side, and you will not only not have one critical value, instead you will have two critical values for a two-tail test. One to this side, one to this right hand side. Okay, so if it is a right tail test, you give your whole error alpha to the right and find the critical value. If it is a left tail test, you give your whole alpha, the error that you allow, to the left and find the critical value. If it is a two tail test, you split your alpha into two equal parts and give it to the two sides and find the two critical values like this. You actually need to find one because this is symmetric, right? Once you find this, the opposite sign of this answer will be here, right? For example, if this is 1.6, the other value should be negative 1.6. You don't need to find both, right? The other value will be the opposite sign of the answer you find when it comes to two-tail tests, right? Okay. Now, what kind of a test is this? Two-tail test. So what do you need to do? You need to split your alpha into two parts. Okay. So alpha here is 0.01. Okay. Now if you split 0.01, your alpha is 0.01. If you split your alpha into two parts, you will have 0.005, right? So that means you find the critical value like this. You will have 0.005 to this side, 0.005 to that side. Okay. You should know how to find this value, the z value, when you know the probability, right? When you have 0.005 to the left, the value here can be found as 2.575. Okay. And you simply need one value because the other should be the opposite sign of it. If this is negative, this should be positive 2.575. Okay, so this is how you find the critical value. Okay, so what do? You split your alpha into two and look in the standard normal table for this z value. Okay, I hope you know how to look for the z values in the z table when you know the probabilities, right? If you don't know it, you can simply speak out right now. I can explain that. Okay, right. So then what else you need? Now you found the critical value, right? So to find the critical value, the ingredients that you need is alpha. Okay, alpha is 0.01. So you can find the critical value here, right? Actually, you have two critical values, right? Here, because it is a two-tailed test. So the critical values, I would say, are plus and minus 2.575 here. Okay. Okay. We need one more thing. That is, we need to compare this critical value with some other value. That is called the test statistic value. Okay. So what is the test statistic value here? Now, again, for the test statistic value, there are two equations. Okay. In under chapter 9, you will see those two equations. Let's see. Chapter 9, z test statistic value. Okay, there are two test statistic values, z and t. Okay. The z test statistic value is x bar minus mu naught sigma over square root n, and t's test statistic value is x bar minus mu naught s over square root n. Again, you pick the correct one depending whether you know sigma or whether you don't know sigma. That means sample standard deviation is given, right? If the population standard deviation is given, you can use this. If it is not given, instead sample standard deviation is given to you, then you have to pick this. Okay. So let's read the question again and check whether the population standard deviation or sample standard deviation is given to you. It is very clear that sigma is 7. What does sigma represent? This is the population standard deviation, right? Therefore, for this particular question, you have to use this x bar minus mu naught divided by sigma over square root n as the test statistic value. Now, I haven't mentioned how to get to the final conclusion yet, right? What I told you up to now is there are, in the critical value approach, we need two things to compare with. One is the critical value or values. We found it. Now, the next thing is the test statistic value. That's what we are finding right now, right? Later on, I will tell you how to get to the final conclusion. Okay. So, um, so the test statistic value here is a z value is x bar minus mu naught over sigma over square root n. Okay, so x bar is given as 21. All the things are given straightforward, right? X bar is 21. Mu naught is the value under the null hypothesis, h naught. In other words, when you look at h naught, it says mu equals 18.7. Okay, so this is nothing but mu naught. This value here under the null is mu naught. So mu naught is 18.7. Okay, when you need to find mu naught, you always look at the null hypothesis and you will see the value here, right? Divided by sigma, which is how much? Which is 7 over square root n. The sample size is 11. Okay, all the things are given in this question, right? Everything is given. So this will end up in one value, right? So you will see that when you do this calculation using the calculator, right, you will end up in getting how much? 1.09. It should be 1.09 because all the answers have 1.09 there, right? Okay, so it should be 1.09, and there's negative 1.09s, but I'm sure that this is positive, right? So it should be 1.09. You do the calculation using the calculator, you will get to this answer, right? Now we have two things. What are the two things? The critical value, in this case critical values, um, because it is a two-tailed test, and the test statistic value, which is 1.09. Now I'm going to tell you how to make the conclusion. Okay, making the conclusion means to decide whether the null is correct or wrong. That's the final conclusion that you need to make in these types of questions. Okay, right. So okay, now how do you make this conclusion? let me, yeah, just give me a second. My computer is not working properly. It's not showing me the cursor. So, okay, okay, now it has. Okay, right. Okay, now we have these two values. We have the critical value and the test statistic, right? Now, this is how you make the decision. You first find the critical value, okay? You find the critical value or values, right? If it is a, okay, let me first explain it in general. If it is a right tail test, okay, starting from the critical value, the critical region, we call this the critical region, is towards the right, okay? If it is a left tail test, starting from the critical value, usually the critical value will be negative for a left tail test, so I will mark it here, right? Critical value, region to the left hand side will be your critical region, okay? If it is a two-tail test, then you will have two critical values, critical value 1 and critical value 2, let's say, right? Area to the left from this lower critical value, area to the right from the higher critical value will be your critical region, okay? So these are called the critical regions, okay? Now what you need to check here to make the conclusion is this: check whether the value, the test statistic value, falls into the critical region or not. If the value falls inside this critical region, you reject the null. If it falls to the safe region, you do not reject the null. Simple as that, right? Okay, so let's do it for this particular question. Okay, for this particular question, you have for this particular question, you have these two values. So it is a two-tailed test. So you will have two critical regions, right? So it is not a right tail test or a left tail test here. It is a two tails test. So your critical region should look like this. I will write it like this. Starting from 2.575 towards the right, you will have one critical region, and starting from negative 2.575 towards the left, you will have another critical region. Now let's check where this test statistic falls. 1.09 is the test statistic value. Is it in this region? Is it in this region? Or is it in this safer region? If it falls to here, we reject the null. Or if it falls to here, we reject the null. If it is in between, in this safe region, we do not reject the null. Those are the two. This is how you make the decision, right? So 1.09 is somewhere in between these two values, right? It is in the safe region. So the answer should be do not reject the null. Okay. So question number 44, sorry, 43, the answer is going to be B, which says Z value is 1.09, critical value is plus or minus 2.575, and the correct decision is do not reject the null. Okay. Okay. Next question. Question number 44. It is the same, right? It is kind of the same, but there is a difference. What is it? Here you will see that sigma is given to you in 43, but in 44 sigma is not given, instead S is given. S means the sample standard deviation is given. If the sample standard deviation is given to you, you have to use a different equation to find the test statistic value. Okay. Again, the alternative hypothesis is a two-tailed one. Okay. So the alternative, looking at the alternative is very important, right? It is not equal to, that means this is a two-tailed test. That means when you're finding the critical value, you have to split your alpha into two parts and find two critical values. So alpha, let's find the critical values first. Alpha is 0.1. If you split it into two, you will end up in 0.05. So 0.05 to this side, 0.05 to the other side, and you find these two values using the standard normal table. You will find that this is 1.645 and negative 1.645. Okay. Oh, no, made a mistake there. You cannot use the standard normal table to find it. Why? Because this is a t-test, not a z-test. Sorry, I made a mistake there, right? You have to work with the t-table, not with the z-table here, right? The reason is standard deviation, the population standard deviation is not known. Instead, the sample standard deviation, S, is given to you, right? If sigma is given to you, you work with the standard normal table, right? If S is given to you, you have to work with the t table always, right? Okay. You find the values from the t table, and when you're working with critical values, you have to use the t table to find them, right? If S is given to you, right? So here, S is 14.2, right? And how do you find the critical value? It is going to be t alpha over 2 comma n minus 1. So t alpha over 2 is 0.05 because alpha is 0.1, alpha over 2 is 0.05. N minus 1 is 19. Why? Because the sample size is 20. 20 minus 1 is 19. Okay. So let's look for t 0.05 comma 19. In the t table, t 0.05 is here, and 19 you will have 1.729. 1.729. Okay, remember that, right? If the sample standard deviation is given, you have to always work with the t table, not the z table, right? If sigma is given, you work with the z table or the standard normal table, which is this guy. Okay, you work with this if sigma is given. If it is not given, instead of the sample standard deviation is given to you, you work with the t table always, right? Okay, now the t value is 1.729. Now you know that there are two critical values here. So it is 1.729 to this side, and from the other side you will have negative 1.729. Okay, so you'll have two critical values because it is a two-tail test. Okay, now you found the critical values. So the critical values are plus or minus 1.729. There are two values. Now what is the test statistic? The test statistic is, again, you have to use the t-test statistic, which is x bar plus minus mu naught s over square root n. You cannot use x bar minus mu naught sigma over square root n, which we use in the previous equation, right? Because sigma is not known, sigma is not given to you. Instead, s is given, so you have to use this, right? So x bar, everything else, everything needs to find the answer for this test statistic is given in the question. X bar is 137 minus mu naught is the value under the null, which is 132, right? If you look at the null hypothesis, you will see that it is this 132, right? And S is 14.2 divided by square root n, n is 20. Okay, you do the calculation, you will find the answer as 1.57. Okay, now you found the critical value usually if it is a right tail or left tail, critical values if it is a two tail test. So you have two critical values, 1.729 plus or minus 1.729, and then you have the test statistic value which is 1.57. Now how do you make the decision? It is the same as before, right? You'll have this t distribution now. It just looks like the normal with slight differences. So I can draw it in the same way that I draw before, right? So you have 1.729 here and negative 1.729 here. If it is a two-tail test, you will have these two critical regions like this, starting from here to the right and starting from here to the left. Okay. Now you need to check whether this test statistic value falls to this region or to that region. If it falls to this critical region, you reject the null. If it falls to the safe region, you do not reject the null. That's the conclusion, right? So let's see where it falls into. 1.57 is somewhere here, right? It is not in the critical region. So again, the answer should be do not reject the null. Okay. So the answer is clearly mentioned in 44, right? Do not reject the null. Test statistic, sorry, for 44, answer is going to be C, right? Everything is clearly mentioned there. Test statistic 1.57, critical value is correctly given. Do not reject the null. And what that means in words is there is not sufficient evidence to conclude that the mean is different from 132, right? Because the null says mu is 132. Alternative says mu is not equal to 132. Our conclusion is do not reject the null. Do not reject the null means we are saying that this guy is correct, right? Null is correct. Okay. If it is correct, that means we don't have sufficient evidence to say that this is correct, right? That's what this sentence is telling you, right? We don't have sufficient enough evidence to conclude that the mean is different from 132. We don't have enough evidence to say that this is correct, right? That is how we say that the null is correct in words in statistics, right? So we don't tell it straightforwardly that mean is exactly 132. Instead, we say we don't have enough evidence to say that the other guy is correct, right? So that's the way in statistics. Okay. Okay. Right. So that's the end of that. Starting from question number 45 are chapter 11 questions. Okay. Now in chapter 11, I'm not going to uh, you know test you a lot in there, right? So question number of 45, okay, those questions will be easy, right? From chapter 11, I will only include some easy questions, right? Okay, uh, so by looking at these questions that I discussed today, you can get some idea of how to prepare for chapter 11 questions. Okay, right. Right. Chapter 11 is about estimating population proportions. Okay, so to estimate the population mean in previous chapters, we use sample mean. Okay. Similarly, to estimate the population proportion, which is denoted by P, we use the sample proportion, which is called P hat. Okay. So let's see how to find it. A proportion you always find out of this much, how many are in favor or how many are in not favor for this something, right? So it's kind of a fraction, right? How many said yes out of how much will be a proportion? How many said no out of 1,000 people will be a proportion, right? So in proportions, you will always see um, number of successes. That means number of observations that are in favor of what we are testing, right? And we find p hat, right? The sample proportion, right? Sample proportion is equal to x over n, which is the number of people that are in favor, the number of observations that are in favor is denoted by x, and the sample size is by n, right? So the number of successes and the sample size are given for a simple random sample from a population that is mentioned in this is question number 45, right? Determine the sample proportion p hat. P hat is simply x over n, right? So x is given as 3, n is given as 16. So p hat is simply 3 divided by 16, which is 0.188, which which is b, right? 46. Okay. Right. So actually, I have decided not to include any uh, kind of you know, interval estimation or hypothesis testing questions from chapter 11. Okay, from chapter 10 there will be, right? Don't misunderstand this. From chapter 11 I will not include any you know, uh, hypothesis testing questions or interval estimation questions. Therefore, you can skip question number 46, 48, 49. Okay. Okay. So question number 46, 48, 49, you can skip, because 46 is talking about a margin of error. I will not ask margin of error under chapter 11, but I will ask margin of error from chapter 10, 9, and 8. Okay. So, sorry, not chapter 10. Chapter 10, you don't need to worry. I skipped that. Chapter 9, chapter 8, right? From chapter 8 and chapter 9, you need to know these things. But for chapter 11, you don't need to, right? Got it? Chapter 8 and 9, you should know how to find margin of errors, how to find interval estimation, how to find hypothesis, how to do hypothesis testing, everything you need to know, everything you need to know, right? But under chapter 11, I decided not to test these things under chapter 11, right? Sorry, for question number 46 about margin of error, 48 is on interval estimation. I will not test that under chapter 11, right? 49 is about hypothesis testing under chapter 11. So I will skip those three things, right? To make, you know, life a little bit easy for you, right? Because this is a summer semester. I will exclude some parts from chapter 11, which is the end part, right? Because I feel some of you might not have time to go through all of these. So chapter 11, I will very briefly ask very simple few questions from chapter 11, right? So the questions from chapter 11 will be very easy. One is given here, right? This type of a question will be there, okay? And the other is again a very easy question. Question number 47 is what I'm going to discuss next, okay? 46 I'm going to skip, 48 skip, 49 skip. What I'm going to discuss today is out of chapter 11, 45, which I already discussed, 47, and 50 and 51. Okay, you will see 47, 50, and 51 are kind of the same type of questions. Okay, so let's see. 47. This is very easy, right? The number of successes and the sample size are given for a simple random sample from a population. Decide whether using one proportion Z interval procedure is appropriate. Now, when it comes to sample proportion testings or interval estimations, you need to test beforehand whether you need to test for two assumptions beforehand, right? If these two assumptions are violated, we cannot do a hypothesis testing or interval estimation for those sample proportions. Okay, so the thing you need to test is this: n has to be greater than or equal to 5. N minus x has to be greater than or equal to 5. Okay, so you will see it here under chapter 11. There's a lot of equations, right? But yes, um, yes, this is what we need to test. Both x and n minus x, sorry, I made a mistake. Both x and n minus x has to be 5 or greater. Okay, x and n minus x has to be 5 or greater. That's all you need to test here, right? So if any of these two assumptions is violated, you cannot proceed to anything, right? So here x is 18, n is 30, so n minus, so we need n minus x, which is 30 minus 18, which is 12. So x is 18, which is greater than or equal to 5, good. N minus x is 12, which is greater than or equal to 5, which is good. So the answer is, if both satisfy this, you can use the C interval procedure, or that is appropriate in this case, right? If any one of these two, for example, if x is, let's say, 4 and n minus x is 10, this is less than 5, right? If something like this happens, right? If any one of these two things fail, so this is a failure here, right? You cannot use any procedure. So the answer should be not appropriate if any one of these assumptions is failed, right? In this question, both assumptions are satisfied, so therefore appropriate. 48, I'm going to skip. 49, skip. 50. Again, the same thing, right? You have x 88, n 250. So x 88 is definitely greater than or equal to 5. Then you have to check for n minus x, which is 250 minus 88. I'm sure that it is greater than or equal to 5, right? The answer for n minus x is greater than or equal to 5. So both assumptions are satisfied. Answer appropriate. Okay, I can say A. 51. X is 5. X has to be greater than or equal to 5. Is it satisfying this condition? It just satisfies it, because it just satisfies the condition because you have this equality sign included, right? So x equals 5 satisfies this condition. Okay, good. N minus x, here n is 44 minus 5 39. That definitely satisfies this condition, so again appropriate. 51 is also appropriate. Okay, so we didn't found anything that is not appropriate in all the three equations. But if any, if in the question, if any one of these two conditions, x or n minus x, falls below 5, then your answer should be not appropriate, right? Okay, okay, so I discussed some of the questions, and the main reason that I took this live session is that I decided to exclude some of the parts from the final exam, right? And now you can understand which parts you need to focus on. Especially in chapter 11, I have excluded uh, several things, and I will only focus on few things, like finding the sample proportion, just like in 45 question, question number 45, and checking whether this C interval procedure is appropriate or not, right? So those are the only things that I would test under chapter 11. But up to chapter 10, you should know everything, okay? Not including chapter 10, up to chapter 9, sorry. Okay, up to chapter 9, including chapter 9, you should know everything, all the things, right? In chapter 11, chapter 10 we skipped, right? You don't need to worry about chapter 10 at all. Chapter 11, you need to focus mainly on these few things that I mentioned today right now, okay? So I hope that will make things easier for you and get ready well for the exam. Um, and if you have any questions, you can go ahead and ask right now, okay? Any questions? And I went through these questions fairly quickly, right? Because I assume that most of you, all of you are comfortable with the theories that I posted on Blackboard, and you have worked through it and done the homework. So I assume that you're okay with the theory part. So I didn't try to explain a lot of theory. I try to go through the questions fairly quickly. But if you have any questions, uh, if you want me to re-explain some parts, or if you want me to do some of the questions that are in the beginning, you can go ahead and speak. Okay, seems like no questions. All right then, I wish you all the best for the final exam. And yeah, if you have done the work, it will be very easy. And this is a very good class actually, right? Most of you are in a very good shape for A, right? And most of you are doing really well, right? So I'm very happy about this class, and I hope you will do well in the final as well, right? So don't get stressed too much. Most of you are in good shape for A, right? But having said that, you have to do well in the final, definitely, right? Uh, I wish you all the best for the final, and if you have any questions, always feel free to email me, and I will email you back. And if you cannot, if you cannot understand those answers, I can take an individual Zoom session with you, right? So to answer those questions. Right. So that's it. So I'll stop from here. And yeah, that's all I have to say, and goodbye. Okay. Yes.
Thank you.
Uh, anyone wants to speak? Let's see. I can't see the chat. Let me see the chat. Oh, okay. All right. Thank you very much. Okay. All right. Bye bye then.